In this video, we're going to look at how to find the volume of three-dimensional shapes. And we're going to stick with the regular shapes for this exercise here. And our regular geometry three-dimensional shapes can be classified in a couple of ways. And the first one will be a prism. A prism is a three-dimensional shape where you have a base, so let's say whatever my base is. It will, on the opposite side of this three-dimensional shape, it will have the identical base, and it will be parallel. So the bases are parallel, and they are connected by a height. So the height of this shape would be the purple. And so the way you would find the volume of a 3D shape classified as a prism, so the volume is going to equal the area of the base times the height. So area of the base times height. Now, a second classification for three-dimensional shapes would be a pyramid. A pyramid has its base, so whatever the base is, so one of our geometric shapes. And all pyramids will come up to a point somewhere, so all of the vertices of the base, or sides of the bases, will come up to a point. And so anytime I have this kind of shape, the way I would find the volume is equal to 1/3 times the area of the base times the height. Well, they will give you the height. The height is the distance the apex is, or the top of the pyramid is, perpendicular to the base. So that's how I'd find the volume of a pyramid. And the third kind of shape that you encounter for regular geometry is a sphere. All right, so sphere, which would be our ball, it has its own volume formula, which the volume would be 4/3 pi r cubed. All right, so those are the common ways to find the volume of three-dimensional solids. And so we'll do a couple of examples for each one. So let's look here. We'll look at number 2. Now you start by identifying the kind of three-dimensional shape we hear, and we have a prism here. Because I see, and I'm going to identify what my bases are. It doesn't, these 3D shapes do not always sit on their bases. I'm looking for identical sides that are parallel to one another. So I see that triangle that I highlighted, and on the opposite side of this figure, we have the same kind of shape. And so our base here is a triangle. And our height is going to be the length of the side that connects the two. And so I'm looking, and this side here is my height. All right, so we know we have the height is equal to 4. And so our volume of this prism is going to equal the area of the base. Well, that's a triangle. So it'd be 1/2 times, well, the base of the triangle is 8, and the height of the triangle is 6. And then, so the area of the base times the height will give me my volume. And so the volume of this shape here in number 2 is 96. Now volume is three-dimensional, so I take my units and I cube them. So 96 centimeters cubed. All right, let's go to another one. So I look here at this shape here, and I try to find or determine what would my base be. Now we have a bunch of sides that are parallel to one another, but your bases, commonly, unless I have a cube, your base is going to be the shape that you see one of them on the top and one of them on the bottom. And they're parallel to one another, and they're connected by some side, some length of a side that is perpendicular to one another. So in purple, we have our bases. They are parallel to one another, so this is a prism. Which means that the volume of my prism is going to equal the area of the base times whatever the height is. Well, we can go ahead and identify the height as the side that connects the two bases. So 9 is my h, is my measure my height. Now to find the area of this base, all right, we have here, we have a hexagon. All right, so and we're given an apothegm. So I have the center indicated, distance straight down perpendicular to a side is 6.9. So what we can do is we can form a triangle that will help us determine the overall area of that hexagon. The area of that individual triangle that I have here is going to be 1/2. Now the base, all sides of these are 8 units. So it'd be 1/2 times 8 times the height, which is the 6.9. Now, there are 6 of those triangles. So when I'm trying to find the volume, so there's 6 of those triangles to make that hexagon that I put together. So to find our volume of this hexagonal prism, the area of our base is going to be 6 times the area of that one triangle that was indicated. 6 times 1/2 times 8 times 6.9. And then times the height, which we said was 9. And so we multiply that all the way, and then we'll get our volume here, which is 1,490.4 miles cubed. Let's go to another one. All right, I'm looking here at this problem, and I see my base here at the bottom. And from the base, everything goes up to a point. So this has to be classified as a pyramid. Now the volume of a pyramid is 1/3 times the area of the base times the height. Now the height is indicated as the distance from whatever side we identify as the base is perpendicular up to the point where all the sides converge to. So my height, I do know, is 10. Now I got to find the area of my base here, which is nothing more than a triangle. So my base has an area of 1/2 times base times height. Well, remember, base and height of the triangles have to be perpendicular to each other. So we don't want to use the wrong two sides of that triangle since I have all 3. So it'd be 1/2 times 8 times 6 is going to give me my base area. And so my overall volume for this triangular pyramid is going to be 1/3 times the area of my base. So times 1/2 times 8 times 6 times the height. And so we'll get a volume for this problem here of 80 kilometers cubed. All right, now let's look here at number 8. Now I see a cone, and a lot of people will look and say, well, what's the volume formula for a cone? Instead of memorizing a separate formula, we look here and we see the base is a circle. So I have my base. And all the sides converge to a point. So a cone falls under the classification as a pyramid, which means that I can apply my volume formula that says the volume of any pyramid, is equal to 1/3 times the area of the base times height. Now the height in this case is 20. Now I go through and I find the area of my base. Well, my area of my base is a circle. So the area of that would be pi r squared. So pi times 10 squared. And I know my height is 20, so I can plug all that into my volume formula and say the volume of this cone is going to equal 1/3 times pi times 10 squared times my height of 20, which is 2,094 yards cubed. All right, and one more. I look at 10. I see the stereotypical ball look here. This is a sphere. The volume of a sphere, it has its own formula, which is 4/3 pi r cubed. Now in this case, I'm given a diameter. I have to find r. So r in this case is going to be 11. And so the volume here would be 4/3 times pi times 11 to the third power, which is 5,575.28 meters cubed.